In late 2017, humanity received an unexpected visitor from beyond our solar system. Astronomers at the Haleocalb Observatory in Hawaii spotted a faint point of light streaking across the sky. It's an object unlike anything ever seen before. This was Oumuamua, a name that means scout or first distant messenger in Hawaiian. It was the very first interstellar object ever detected passing through our cosmic neighborhood. Its discovery ignited a firestorm of scientific debate and public fascination. Oumuamua wasn't just another asteroid or comet. It was profoundly strange, defying our established understanding of celestial bodies. From its bizarre shape to its inexplicable movement, this interstellar traveler raised more questions than it answered. The most tantalizing question of all was whether it was a natural phenomenon or something far more extraordinary. Could this have been our first encounter with a piece of advanced technology from another civilization? The journey to understand Oumuamua is a story of scientific rigor, bold speculation, and the enduring human quest to find our place in the cosmos. As Oumuamua journeyed through our solar system, scientists scrambled to study it before it disappeared back into the void of interstellar space. What they found was puzzling from the very beginning. Initial observations suggested it was an incredibly elongated object, perhaps 10 times longer than it was wide. This led to the now famous cigar-shaped description, a form unlike any known asteroid or comet in our own solar system. Think about it. Most celestial objects are shaped by gravity and rotation into somewhat spherical or irregular potato-like forms. An object with such an extreme aspect ratio was an immediate red flag that something was different. This unusual shape was inferred from the way Oumuamua's brightness varied over time. As it tumbled through space, it reflected sunlight in a distinct pattern, periodically getting brighter and then dimmer, suggesting a long, thin profile, while later analyses suggested it might be more of a flat, pancake-like object rather than a cigar. The conclusion remained the same. This was not your average space rock. The mystery only deepened when astronomers looked at its composition. Spectroscopic analysis, which studies the light reflecting off an object to determine what it's made of, yielded confusing results. It appeared to have a reddish hue, similar to some objects in our outer solar system that have been exposed to cosmic radiation for billions of years. This suggested a natural origin, perhaps a chunk of rock or a planetesimal ejected from its home star system long ago. However, it showed none of the classic signs of being a comet. As comets approach the sun, their ice heats up and sublimates, creating a visible tail or coma of gas and dust. Oumuamua passed incredibly close to our sun, well within the orbit of Mercury, yet it displayed no such activity. There was no tail, no coma, no outgassing detected by our most powerful telescopes. This lack of a cometary tail was a crucial piece of the puzzle. If it wasn't a comet, it must be an asteroid, a dry piece of rock. But that explanation was about to be shattered by Oumuamua's most bewildering behavior of all. As Oumuamua whipped around the sun and began its journey back out of our solar system, something extraordinary happened. It started to accelerate, pushing away from the sun faster than gravity alone could explain. This wasn't a slight nudge. It was a small but statistically significant deviation from its expected path. Something was giving it an extra push, a non-gravitational acceleration that scientists couldn't immediately account for. For comets, this behavior is common. The outgassing of gas and dust from their sun-warmed surfaces acts like a series of tiny rocket thrusters, pushing the comet and altering its trajectory. This is the most widely accepted natural explanation for Oumuamua's acceleration. The natural origin theory proposes that Oumuamua was, in fact, a very unusual type of comet. Perhaps it was outgassing materials that were simply invisible to our telescopes, like pure hydrogen, nitrogen, or water vapor without the usual dust that makes cometary tails visible. One leading hypothesis suggests that Oumuamua was a nitrogen iceberg, a fragment chipped off a Pluto-like planet in another star system. As it neared our sun, the frozen nitrogen would sublimate, providing the gentle, unseen push that caused its acceleration. This theory elegantly explains both the acceleration and the lack of a visible coma. The nitrogen gas would be transparent, and the object's strange shape could be the result of its parent body's composition and the way it broke apart. Another natural explanation posits that it was a hydrogen iceberg, a chunk of frozen hydrogen formed in the coldest parts of a giant molecular cloud. This would also explain the acceleration. But the existence of such objects is purely theoretical, and they would be expected to evaporate very quickly. These natural explanations, while plausible, require us to accept that Oumuamua was a member of a new, previously unseen class of celestial objects. It was a statistical anomaly, the very first one we happened to see. This is where the scientific debate gets truly fascinating. One prominent astronomer, Avi Loeb of Harvard University, looked at the data and came to a much more radical conclusion. He argued that the natural explanations were a stretch, requiring too many new assumptions. What if he proposed we were looking at the problem from the wrong perspective? What if Oumuamua wasn't a natural object at all? The combination of its strange shape, its lack of a visible coma, and its non-gravitational acceleration pointed towards another possibility, one that science fiction has dreamed about for decades. The extra push Oumuamua received was consistent with the force that would be exerted by solar radiation pressure. Sunlight itself carries momentum and can push on objects, a principle used in the design of solar sails. A solar sail is a proposed method of spacecraft propulsion that uses a large, thin, reflective membrane to catch solar radiation like a sail catches the wind. It's a technology that we ourselves are currently developing for interstellar travel. For solar radiation pressure to be strong enough to accelerate an object the size of Oumuamua, the object would have to be incredibly thin and have a very large surface area relative to its mass. It would need to be essentially a sail. This alien technology hypothesis suggests that Oumuamua was not a rock, but a manufactured artifact. It could be an active probe sent to study our solar system, or perhaps just a piece of defunct space junk. A derelict solar sail tumbling through the cosmos. This would explain its strange flattened shape, which would be ideal for a solar sail. It would also perfectly explain the acceleration without any need for outgassing, thus accounting for the lack of a coma. The idea is, of course, highly controversial within the scientific community. The principle of Occam's razor suggests that we should prefer the simplest explanation that fits the facts. And for many scientists, a nitrogen iceberg is a simpler solution than invoking an alien civilization. Critics of the technological origin theory argue that it is an extraordinary claim that requires extraordinary evidence. And since Oumuamua is long gone, we have no way of gathering more data to prove or disprove it. They contend that we shouldn't jump to an alien explanation just because an object is strange. The universe is vast and full of phenomena we have yet to discover, and it's more likely that Oumuamua is a natural object of a type we've simply never encountered before. However, proponents of the theory, like Loeb, counter by asking what an alien probe or artifact would even look like. We expect to receive a radio signal. But perhaps the first sign of extraterrestrial intelligence won't be a message, but an object. They argue that to dismiss the possibility out of hand is unscientific. We must remain open to all possibilities that the data allows, no matter how unconventional they may seem. Ultimately, we may never know the true nature of Oumuamua. It has already left our solar system and is speeding away into the darkness of interstellar space, never to return. It's a frustrating conclusion to such a thrilling mystery. We had a brief, fleeting glimpse of something truly unique, and now it's gone forever, taking its secrets with it. But the legacy of Oumuamua is not just a collection of unanswered questions. It has fundamentally changed the way we look at the sky and our place within it. Its discovery has spurred the development of new survey telescopes, like the upcoming Vera C. Rubin Observatory, which will be able to detect many more interstellar objects in the coming years. By studying a whole population of these visitors, we can determine if Oumuamua was a one-of-a-kind oddity or the first of many. If we find many more objects like it, the natural origin theory will likely be confirmed. But if Oumuamua remains a complete outlier, its strange characteristics never repeated, the alternative explanation becomes more compelling. Oumuamua forced us to confront the possibility that we are not alone in a very tangible way. It was either a bizarre piece of natural celestial mechanics, or the first physical evidence of technology from beyond our solar system. It was a profound messenger. It reminded us that the universe is stranger and more wonderful than we can imagine, and that there are still incredible discoveries waiting for us out there in the dark. So was Oumuamua really just a rock? A weird comet? Or was it our first brush with a traveler from another star system? For now, the answer depends on who you ask. Data remains a tantalizing puzzle, a scientific cliffhanger, that will inspire astronomers and dreamers for generations to come. Thanks for watching. If you enjoyed this journey into one of space's greatest mysteries, be sure to explore more of our content here on Space Repo.